Okay, our next topic is system of track electrification. So based on the availability of the supply, the track electrification system can be categorized into DC system, single phase AC system, three phase AC system, and composite system. So you can see here types of electric traction system. They are DC system, AC system, and composite system, where AC system is categorized into single phase AC system and a three phase AC system. Single phase AC system, it can be a single phase low frequency system, or it can be a single phase high frequency system. Three phase AC system, it can be a three phase low frequency system. Composite system, it can be single phase to three phase system. You can even call it as condo system, and it can be a single phase AC system to DC system. Let us discuss one by one in detail. So let us start with the DC system. So in this DC system of traction, the electric motors employed for getting necessary propelling torque should be selected in such a way that they should be able to operate on DC supply. Okay, so in this DC system for traction, okay, the electric motors which are used here for getting necessary propelling torque, they should be selected in such a way that they should be able to operate on DC supply. Okay, so example for such vehicles operating based on DC system are tramways and trolley buses. So we have already discussed about the tramways and trolley buses. Okay, so for trolley buses, there is no need of any track, but for tramways, track is required. Okay, so usually DC series motors are preferred for this both for tramways and trolley buses. Okay, DC series motors are preferred for here. And if we want any regenerative braking, instead of using DC series motors for these tramways or trolley buses, we can even use DC compound motors. Okay, so if there is any availability of DC compound motor, if we want regenerative braking, instead of using DC series motors and DC series motors, we can use DC compound motors for regenerative braking. So the operating voltages of the vehicles for DC track electrification system are 600 volts, 750 volts, 1500 volts, and 3000 volts. Okay, the operating voltages for these vehicles for DC track electrification are 600 volts, 750 volts, 1500 volts, and 3000 volts. So the direct current at around 600 to 750 volts is universally employed for tramways in urban areas. Okay, in urban areas, okay, direct current at 600 to 750 volts is universally employed for tramways. Whereas for many suburban and mainline railways, 1500 to 3000 volts is used. Okay, for suburban and mainline railways, 1500 to 3000 volts is used. So in some cases, DC supply for traction motor can be obtained from substation equipments. Okay, in some cases, we can get the DC supply for traction motors from the substation equipments with rotary converters to convert AC power to DC power. So with the help of rotary converters, we can convert AC power to DC power in the substation, and we can utilize that DC power for traction motor. Okay, so these substations will receive AC power from the three-phase high voltage line or single-phase overhead distribution network. Okay, so that you people already know. Okay, the substations in which rotary converters are used to convert AC power to DC power to supply the traction motor. Okay, these substations will receive power from a three-phase high voltage line or single-phase overhead distribution network. Okay, so the operating voltage of for traction purpose, it can be justified by spacing between the stations and the type of traction motors available. Okay, so these substations are usually automatic and remote costlier since they involve rotary converting equipments. Okay, since we are using rotary converting equipments in the substations, they are very costly. Of course, they are automatic and remote controlled. The DC system is preferred for suburban services and road transport where stops are frequent and distance between the stops is small. Okay, so DC track electrification is preferred for suburban services and road transport where stops are frequent. Okay, and the distance between the stops is small. Okay, so next one is single phase AC system. So in this system of track electrification, usually AC series motors are used for getting the necessary propelling torque. Okay, so in order to get the necessary propelling torque, okay, so I have written here power. Okay, so but in order to get the necessary propelling torque for these vehicles which use the single phase AC supply, okay, AC series motors are preferred. So the distribution network employed for such traction systems is normally 15 to 25 kilovolts at a reduced frequency of 16 to 3rd hertz or 25 hertz. Okay, so the frequency is reduced, okay, from normal frequency to a low frequency of around 16 to 3rd hertz or 25 hertz. So the main reason of operating at reduced frequencies is AC series motors. Okay, so because these motors are more efficient and show better performance at low frequencies. Okay, so why we are reducing the frequency of the supply? The reason behind that is we are using AC series motors here, and these AC series motors are more efficient and show better performance at low frequencies. Because of that, we are reducing the supply frequency. Okay, so these high voltages, that is around 15 to 25 kilovolts, it can be stepped down to a suitable low voltage of around 300 to 400 volts by means of some step down transformer. Okay, so the voltage can be stepped down by using a step down transformer, that is from 15 to 25 kilovolts to 300 to 400 volts. And we even want to reduce the frequency, isn't it? We want to reduce the normal frequency value to around 16 to 3rd hertz or to 25 hertz. For that, we need a frequency converter. Okay, so low frequency can be obtained from normal supply frequency with the help of frequency converters. Okay, low frequency operation of overhead transmission lines reduces the line reactance and hence the voltage drop directly. Okay, so by reducing the frequency, we are able to reduce the line reactance of the overhead transmission line, as well as voltage drop is reduced. Okay, so single phase AC system is mainly preferred for mainline services where the cost of the overhead structure is not of much importance. Okay, so if the overhead line cost is not of much importance, in such places we can use single phase AC system. Moreover, rapid acceleration and retardation is not required for suburban services. Okay, so let us discuss about. Okay. three-phase AC system. So in this system of track electrification, three-phase induction motors are employed for getting the necessary propelling torque. Okay. So in this case, we will use in this system, that is three-phase AC system, three-phase induction motors are used for getting necessary propelling torque. The operating voltage of the induction motor is normally around 3000 to 3600 volts AC at either normal frequency or at reduced frequency of around 16 to 3rd hertz. Okay, so in this three-phase AC system for track electrification, we will use three-phase induction motors to get the necessary propelling torque of the vehicles. Okay, and the operating voltage of these induction motors will be around 3000 to 3600 volts at normal frequency, or the frequency can be reduced to 16 to 3rd hertz. Okay, usually three-phase induction motors are preferable because they have simple and robust construction. Okay, so three-phase induction motors are preferable. Why? Because they have simple and robust construction, they have high operating efficiency, okay, and provision of regenerative braking. Okay, so regenerative braking means we can even feedback under offload period, we can feedback the stored energy to the system. Okay, so provision of regenerative braking without placing any additional equipment and better performance at both normal and reduced frequencies possible by using these three-phase induction motors. Okay, so three-phase induction motors are preferable because they are simple and robust in construction. Okay, so their construction is robust and they are simple. They have high operating frequency and regenerative braking is possible without placing any additional equipment. Okay, and they have better operation and better performance at both normal and reduced frequencies. Okay, so in addition to these above advantages, induction motor suffers from some disadvantages. They are low starting torque. Okay, three-phase induction motor has low starting torque, high starting current, and absence of speed control. Okay, so three-phase induction motor suffers with low starting torque. Okay, one of the drawback is it has low starting torque, it has high starting current, and absence of speed control. And one of the main disadvantages of this track electrification is that disadvantage of this track electrification is that high cost of overhead distribution structure. Okay, so because of means we have to spend more for this overhead distribution line. Okay, so from which this three-phase induction motor will take the supply. Okay, so the supply unit, that is overhead unit that is to be connected to three-phase induction motor, is very costly. That is the main drawback. So the distribution system consists of two overhead wires and track rail for the third phase and receives power either directly from the generating station or through the transformer substation. Okay, so the distribution system which gives supply to this three-phase induction motor, it consists of two overhead wires and a track rail for the third phase, and it receives power either from directly from the generating station or through the transformer substation. So this three-phase AC system is mainly adopted for the services where the output power required is high and regeneration of the electrical energy is possible. Okay, so it is used in the systems where high output power is required and regeneration of the electrical energy is possible. In such places, this three-phase AC system is used. Next is composite system. Till now we have discussed DC system, we have discussed single phase AC system, we have discussed three phase AC system. Okay, so all these systems, DC system or single phase AC or three phase system, they have their own merits and demerits, means they have their own advantages and some disadvantages. Okay, so if you go to a single phase AC system, single phase AC system is preferable in the view of distribution cost. Okay, so the cost of distribution for single phase AC system is low, so it's an advantage. And the distribution voltage can be stepped up to high voltage with the use of transformers, which reduces the transmission losses. Okay, so you can even vary the voltage level. Okay, for distribution. Okay, simply by stepping up the voltage. Okay, uh, for transmission purpose. Okay, so if you step up the voltage, what will happen? Will be lost. I don't know whether I'm still in the Okay, so we have been discussing about the composite system. So whatever systems that we have discussed till now, DC system, AC system, single phase AC, three phase AC systems, all these systems have their own merits and demerits. Okay, so if you consider a single phase AC system, so single phase AC system is preferable in the view of distribution cost. Okay, distribution cost of single phase AC system will be low. Therefore, it is an advantage of using single phase system AC system. Okay, and we can even for this distribution voltage can be stepped up to high voltage with the use of step-up transformers. And whenever we are able to step up the voltage level, then the transmission losses will reduced. Why? Because when you step up the voltage, the cross-section of the conductor for transmission will be reduced. Okay, when the cross-section of the conductor of the transmission is reduced, means it is allowing low current at high voltages where we want to transmit the power. Okay, so when the cross section of the conductor has reduced, definitely the transmission losses are reduced. So this is the advantage of using single phase AC system. So when we go to a DC system, DC series motors have most desirable features. That is the advantage of DC system. So if you go to a three-phase system, three-phase induction motors have the advantage of automatic regenerative braking. Okay, so each system has its own advantage. So it will be better if we are able to combine these systems together to have much more better operating system. So it is necessary to combine the advantages of these systems. Okay, so we can combine DC and AC, three phase and single phase. Okay, so this leads to an evaluation of a composite system. So when we combine these systems, then it becomes a composite system. So composite systems can be categorized into two types: single phase to DC system and single phase to three phase system. Single phase to three phase system, you can call it as a condo system. Okay, so you can categorize this composite systems into single phase to DC system or single phase to three phase system, and single phase to three phase system you can call it as a condo system. So let us discuss single phase to DC system. So in this system, the advantages of both single phase and DC system are combined to get high voltage for distribution in order to reduce the losses that can be achieved with single phase distribution network, and DC series motor is employed for producing the necessary propelling torque. Okay, so finally, single phase AC distribution network results into minimum cost with high transmission efficiency, and DC series motor is ideally suited for traction purpose. So normal operating voltage employed for distribution is 25 kilovolts at normal frequency of 50 hertz. So this track electrification is actually employed in India. Okay, so in India, a single phase to DC system composite system is used. Okay, so where the normal distribution voltage of 25 kilovolts at normal frequency is used for track electrification. Okay, so next one is single phase to three phase condos. We can even call it as condo system. Okay, in this system, single phase AC system is preferred for distribution network since single phase overhead distribution system is cheap. Okay, since single phase overhead distribution system is cheap, therefore single phase AC system is preferred for distribution network. Three phase induction motors are employed as traction motors because of their simple and robust construction and provision of automatic regenerative braking. Okay. So the voltage used for the distribution network will be around 15 to 25 kilovolts at 50 hertz, and the single phase supply is converted to three phase supply with the help of phase converters and high voltage transformers to feed the three phase induction motors. In this composite system, single phase supply is converted to three-phase supply with the help of phase converters and high voltage transformers to feed the three-phase induction motors. Okay, so frequency converters are also employed to get high starting torque and to achieve better speed control with variable supply frequency. Okay. So let us see the comparison of DC and AC traction. In cost point of view, DC series motors are cheaper when compared to AC series motors. Okay, and when you compare the efficiency of DC traction with AC traction, okay, DC traction is more efficient when compared to AC traction. And if you compare the maintenance of AC traction with DC traction, okay, DC traction requires less maintenance when compared to AC traction. And if you compare the acceleration of both the tractions, then DC traction is capable of giving high acceleration. The motors that are used in DC traction, they are capable of giving high acceleration. Okay, whereas the motors that are used for AC traction, they are capable of giving less acceleration. So if you compare the speed control of these two tractions, the speed control of DC series motor is limited, but wide range of speed control is possible in the case of AC motors. Okay, so if you compare the interference, DC system causes less interference with the communication lines, but AC traction system will produce more interference with the communication lines. Okay, so regenerative braking is more efficient in DC series motor. Regenerative braking is less efficient in AC series motors. Okay, so overhead distribution is possible for both DC traction and AC traction. Okay. And DC system is less costly, whereas AC system is more costly. If you compare the torque developed by the DC series motor is less. The starting and the running torque developed by the AC series motor is more. And the number of substations required for a given track distance on DC traction is more. The number of substations required in AC traction is less. Okay, so this is the comparison between DC and the AC traction. So let us discuss some special features of traction motors. So the general features of traction motors used for traction purpose are mechanical features and electrical features. Okay, so let us discuss about this. And it should be capable of withstanding severe mechanical vibrations. Okay, so the traction motor which is used for traction purpose, okay, it must be mechanically strong and robust, and it must be capable of withstanding severe mechanical vibrations. So the traction motor should be completely enclosed type when placed beneath the locomotive to protect against dirt, dust, mud, etc. Okay, it should be completely enclosed to protect against dirt, dust, etc. Okay. In overall dimensions, the traction motor should have a small diameter to arrange easily beneath the motor coach. Okay, so its dimension should be small enough so that it can be easily arranged beneath the motor coach. Traction motor must have minimum weight, so the weight of the locomotive will decrease. Okay, if it has minimum weight, the weight of the locomotive will decrease, and hence the load carrying capability of the motor will increase. Okay, so this is the mechanical feature. Next is the electrical feature. So electrical features are high starting torque, speed control, dynamic and regenerative braking, temperature, overload capacity, and communication. Okay, so let us start with high starting torque. So a traction motor must have high starting torque, which is required to start the motor on load during the starting condition in urban and suburban services. Okay. Next one is speed control. The speed control of the traction motor must be simple and easy. This is necessary for frequent starting and stopping of the motor in traction purpose. And next is dynamic and regenerative braking. Traction motor should be able to provide easy, simple, rheostatic and regenerative braking. Okay. Subjected to higher voltages, so that system must have the capability of withstanding voltage fluctuations. Okay. So next is temperature. The traction motor should have the capability of withstanding high temperatures during transient conditions. Okay. So the traction motor should be able to withstand high temperatures during transient conditions. Okay. Next electrical feature is overload capacity. The traction motor should have the capacity of handling excessive overloads which are parallel running. In traction work, more number of motors need to run in parallel to carry more loads. Okay. Therefore, the traction motor should have such speed and torque and current torque characteristics that these motors must share the total load almost equally. Okay. So all the motors which are running in parallel must be able to carry all the loads equally, distribute the load equally. Okay, next factor, electrical feature is commutation. The traction motor should have the feature of better commutation to avoid the sparking at the brushes and commutator segments. Okay, so sparking at the brushes and commutator segments should be avoided. Okay, so it should have better commutations. So these are the special features of traction motor.